Argument forms and fallacies. Now we're going to be going to section 6.6. This is the last chapter that you will have to be responsible for before set 4 and test 4 answers are due. So what we're going to do here is talk about argument forms or skeletons that are valid. The bones are lined up correctly, and you need to kind of understand, you need to understand these forms, why they're valid, and know how to recognize them. Okay, a lot of them we're going to use variables. If P, then Q, P, therefore Q, P, Q, R, S. It can go up to S if you have 4 variables in terms of the examples I'm going to show you. But you need to understand how to recognize a skeleton when you're looking at an actual argument that has propositions or different letters representing propositions and not P's and Q's. And in a sense, you always want to see the P's and Q's beneath whatever you're looking at. Okay? I'm trying to think of the movie The Da Vinci Code. I don't know if you saw it, but they kind of in the movie highlighted the clues. You know, they kind of highlighted a little bit in the film. That'll be meaningful for some of you who've seen the movie. You want to do the same thing if you're looking at arguments. You want to see the if P then Q, P therefore Q lurking behind an argument that you're looking at, okay? So let's go over these. Some of them I've already shared with you, but let's start. Okay, many of the arguments that occur in propositional logic have forms that bear specific names and can be immediately recognized as either invalid or valid, and that's helpful. If you can look at something and go, oh, the skeleton here is if P then Q, P therefore Q, even though it's different letters or it's actual sentences, well, I already know that's modus ponens and that's valid. So you see, this can be helpful. And again, with these argument forms, we're going to be able in Chapter 7 to do further things. We're going to be able to infer other lines and even determine if we can derive certain conclusions, okay? So let's start with the first one, and this will all start making more sense to you. Maybe I should define, you know what an argument form is. This is repetitive. It's an arrangement of statement variables with an operator such that the uniform replacement of the variables by statements results in an argument. So right here, here's an argument form. If P then Q, P therefore Q. It's a common one. It's valid. We name it modus ponens. Okay. I could have if it's raining outside could be P, then the streets are wet could be the Q. It's raining outside, therefore the streets are wet. Well, there you would have a valid argument. Okay. And the skeleton beneath that is if P then Q, P therefore Q. And what's interesting, if these are valid arguments, what do you think is going to happen if we test them with a truth table? Well, let's do that for this one here. If we were going to put this into a truth table over here, if P then Q slash P double slash, right, Q. Okay, so this is going to be a 4-line truth table, right? So we come over here, true, true, false, false, and we can duplicate the P here, true, true, false, false. Q would be true, false, true, false, and let's duplicate it, true, false, true, false. And you got to remember, if this is a valid argument, we should not find a line where the premises are all true and the conclusion is false. So we just have to look at these 2 rows. When you're trying to find that row, you could ignore the other ones, because you remember the conclusion has to be false. So we look at this line here. We've got a true premise there, and we've got to decide if this premise is true. So let's quickly finish the truth table. This would be true, false, true, true, right, for the conditional. And right here, we don't have both premises true and false, and here we shouldn't find both premises are true. We have one is true and one is false right here. So we don't have that line, so this truth table tells us This argument is a valid form because we can't find a row where the premises are true and the conclusion is false, which is what you would expect with a good skeleton. A valid good skeleton, if you put true premises in there, will never deliver a false conclusion, and that's exactly what we find out. So that's what it means here when we say a valid argument form will satisfy the truth table test. We can do a truth table, and we're not going to find a line with all true premises and a false conclusion anywhere in the truth table. Okay, so this one, if P then Q, P therefore Q, you've seen this before. This is valid, and what you want to understand about this is that whatever P is here, you're affirming P again. And if you have if P then Q, P, therefore Q. And this is when you have modus ponens. So what you want to notice is the P and the P are the same, okay? If whatever this proposition is, this proposition has to be the same thing. This antecedent. Whatever this consequent is, the consequent has to be the same. So technically, you could have something like this. You could have if not P, then Q. As long as you put not P again, therefore Q, it's still modus ponens. And you would abbreviate modus ponens MP. Okay? Now what if you did this? If not P, then Q, if you changed not Q to a tilde, as long as this is the same thing, a tilde, because Q, Q, right? So these have to be the same, it's still modus ponens. Now if I took my eraser and I erased that, this would not be modus ponens, because modus ponens is if P then Q, P again, therefore Q. Here we have if P then Q, not P, therefore not Q. I mean if P then not Q, not P, therefore not Q. This is not modus ponens because these two, P and not P, are not the same. Okay? So if you replace the P's and Q's with something else, it would be the same thing. So let's reiterate that again here. How about if we had if S, then T, S, therefore T. Now that is modus ponens. But if we had if S then T, not S then T, that is not modus ponens because we don't, the S is the P and the not S is not P. And this isn't P, if P then Q, not P, therefore Q. The antecedent, S and, S is the P technically, T is the P. These two have to be the same. So because this has a not S, that would not be modus ponens. But if we made this not S, then it would be modus ponens because these again are the same. Okay? So the point is the relationship is more important than where exactly a tilde is or things like this. Okay? If this is the antecedent, you have to affirm the same antecedent again to get the same consequent. All right? Okay, so that's modus ponens, and you're very familiar with that because I've been saying if it's raining outside, the streets will be wet. It's raining outside, therefore the streets are wet. Okay, then we have, and modus ponens means affirming mode. You were affirming the antecedent here again. Denying mode, modus tollens. This is if P then Q, not Q, therefore not P. And if we went ahead and did a truth table for this, this is a valid form. You are not going to find a truth table. You're not going to find a row or a line in the truth table where all the premises are true and the conclusion is false. Okay, so this would pass the truth table test. I'm not going to do it, just trust me. Modus tollens is a valid argument form. And let's, even if we put in rain and the streets are wet, this would be if it's raining outside, then the streets are wet. The streets are not wet. Okay, that's a W. The streets are not wet. Well, let me clean that up here. The streets are not wet, therefore it is not raining. And that is modus tollens. It's valid. It makes sense. If it's raining outside, the streets are wet. The streets are not wet, so we know it's not raining. And what you want to understand here, and I'm sure you're already seeing this, is that if you had these out in sentences, or even the R, the W, the not R, do you realize the R is the P, the W is the Q, the not W is the not Q, the not R is the not P. And so it's really if P then Q, not Q, therefore not P. Okay? So that's modus ponens, and then if we just mix things up here with it, if you had if R then W, W, therefore not R, that is not modus tollens, okay? Because these two have to be opposite. If it's W, you're negating the consequent. Here the consequent is not negated. But what if you had not W? Let's change this to not W. This would be modus tollens, because remember, if we go back here, pay attention to the relationships. If P then Q, not Q, therefore not P. Not Q and Q are opposite. You are negating the consequent, therefore you can negate the antecedent. So here, you are negating the consequent. If the consequent happens to be not W, then W is the opposite. And then you're able to affirm the opposite here. So this would be modus tollens. So remember, it's go back to the original if P then Q conventional argument skeleton form, because these are variables, and pay attention to relationships. Here you're negating the consequent. You can negate something. If you have Q, its negation is not Q, right? But if you have not Q, its negation would be Q. So that's why here we still have negation, so you still have it there. Okay, let's go to the next one. This is disjunctive, and this one here is abbreviated MT. Okay. Over here, this one will be abbreviated DS. And here is the conventional argument form. If it's not if, I'm sorry. Either P or Q, not P, therefore not Q. And this is called inclusive. What this means, what inclusive means is that it has to be at least one of the disjuncts. This first premise is a disjunction. You have two disjuncts. You have a disjunct on the left, P, and one on the right, Q. And what this is saying, if P then, I'm sorry, I'm getting confused with this one. Either P or Q, not P, therefore Q, it at least has to be one, but it could be both, okay? At least one of the disjuncts is true. So if at least one is true, if you knock one off, you see this is negated. These two are opposite. It's P and not P. The tilde position is as important as the fact that these two are going to be opposite. If at least one of them has to be true, and you cancel out one of them, the other one has to be true. That's why either P or Q, if it isn't P, and it has to at least be one, we know for certain it has to be Q. Okay, so let me give you some examples here and mix things up. What if we had either not P or Q, P, therefore Q. Is this DS? Yes, because see, the tilde is in the wrong. It's not in the wrong. It's in a different position. Here it was down on the second premise. Here the tilde is in the first disjunctive premise. If you have not P and then you affirm P, these cancel out as much as these cancel out, and then you can affirm P. You can affirm Q as the conclusion. That is DS. Okay? What about if we had this? Either P or Q, not P, therefore not Q. This is not DS, because here in DS is your first premise, the disjunction. If you knock one of them off, you have to bring whatever this is down. But you're not bringing whatever this is, you're negating it. These two are not the same. But here, the right disjunct is the same as the conclusion. See? The same, the same. Now, if I went ahead and put a tilde here, that would be DS. Let me make that more clear here. Okay, there would be DS. So you're saying the way to understand this is these are negating, these are the same. Okay? That's what you want to figure out. And so if we had either G or D, not G, therefore D, that's going to be DS. Okay? Now, what about this? You remember I said it has to at least be one, but you have no guarantee it's more than one. So if you have something like this, either P or Q, right? P, therefore Q. This is not disjunctive syllogism, no. Because we haven't knocked one off. It could be P, but remember it says down here at least one. It doesn't say it has to be two. So you could have at least one P, but you have no guarantee it's Q. So you can't bring down Q, because these are deductive arguments, with 100% certainty. Now if you knock off P and it at least has to be one, you could bring down the Q. But if you don't, if you just affirm P, you don't know that you can affirm Q, because it at least has to be one. Maybe it's just the one and it's not both. You don't know if it's both. You only know at most that you got to have one, so if you knock one off, it has to be the other. Okay? And we'll do the one more for this video, and then we'll do part 2. This is hypothetical syllogism. It basically says if you have a P, then you have a Q. And if you have a Q, notice here, if Q is here, Q is going to be here. So these have to be the same. If P, then Q. If Q again, then R. If you have a situation like this, you're allowed to conclude if P, then R. Now notice you could do something like this. Let's say you have if Q, then R. If P, then Q, and then conclude, therefore, if P, then R. This, and we abbreviate this HS, this is still HS, okay? So you've got to be careful. All I did is I switched. You don't have to have the order. Even up here, I could have not P, P or Q, and Q. This is still DS, so you want to be careful, okay? Just because I switch the order of the premises, if it's valid, it doesn't change anything, okay? And sometimes some of your problems, you're going to get them switching it to see if you can still recognize, for example, down here, if you could recognize that this is HS. And here's why. If P, then Q, Q again, then R, it does equal if P, then R, so that is still HS. Now, if I had some examples here, okay, let's do this. If S, then T. If T, then G. This would be if S, then G. If S, then T. If T again, then G. That's HS. And let's just make sure you can see the Da Vinci Code kind of P's and Q's blinking, right? That is the P. This is the Q. Here's the P again, the same exact P, and here's the R. This is the P, and that is the R. So you want to get into the habit of seeing the P's and the Q's and the R's and S's if something is a compound proposition and needs S and R. Okay, now let me erase these right now so we don't make this cluttered here. I'm going to change some stuff up just to make sure you guys are tracking, okay? What if I did this here? If S, then T, and I made this not T. That is not HS because it's not T again, it's not T, and these two are the same. Now, if this was not T, we're fine. Not T again. If we have S being not S, that'll be hypothetical syllogism. You're okay. All right? If this is not G, as long as this is not G. So here, Q and Q is the same, and whatever P is and whatever R is, you have to have it to be the same down here. So if P happens to be not S, as long as this is not S, we're good. If R happens to be not G, as long as this is not G, we are good. So learn how to read them this direction and going up. Okay? This direction here, I can see here's the Q, and I just go this way, right? Well, this way, get used to just going the other direction. Here's the Q, it's going that way, there's the Q, and it comes over here. So learn how to read it that way or how to read it that way. Okay, we'll go to part 2 and I'll go over to the remaining argument forms, but you need to see these forms, these P's and Q's, beneath regular arguments with English sentences or same type of skeletons using different letters, okay, and not getting messed up by the tildes also. Okay, I'll see you in part 2 of this same section.